Students, today I come up with a very important video from the photochemistry. This video not only for the photochemistry, I would like to extend the discussion to the topics of spectroscopy also, so that you can solve some questions, particularly for IIT JAM and other competitive examinations. Therefore, in the beginning, I would like to tell you, this is something extra I am going to tell you. For who are seriously preparing for MSc entrance examinations, watch it carefully, and the subsequent discussion will be shared in our JAM classroom. Okay. For who are not interested in such courses, just watch it and pick up your syllabus contents only. Okay. Now, I would like to have a brief introduction before going to the topics. Now, what happens? This is our question. What happens when atoms or molecules absorb the light, photons? Suppose you have an atom, you give a photon, the atoms absorb it, and there will be excitations in the electronic level. Suppose it is nucleus, your electron is here, and there will be an excitation, A star, excited molecule, that is, now your electron will be probably here. Okay, excitation. Yes, similarly, if you give light to the molecules, what happened to the molecules? There are a lot of things happens. M is molecule. Here only electron, but here there are a lot of things happen. That is, depends upon the energy of the photon. You will have a transition, excitation, transitional motion, or rotational, or vibrational, or electronic. That is, you have a transitional change, or rotational change, or vibrational change, or electronic change. All are possible in molecules. Depends upon the energy of electrons. Okay, so normally rotational happens in microwave region. Suppose the photon from microwave region, rotation happens. If it is in IR region, rotation as well as vibration, both happens for IR region. Okay, if it is in UV and visible, all these happen. Translation happen, rotation happen, vibration happen, electronic happens. If it is microwave, translation as well as rotational happens. If it is IR, all this happens. If it is UV, all these three happens. If it is UV and visible, all this happens. Normally we are not discussing translational because it is a very low energy change. Therefore, it is quantization and calculations are not much significance. Okay. Yes. Therefore, when we are focusing on this UV and visible, our photochemistry is the chemistry because of photochemistry is the chemistry because of photochemistry is the chemistry because of UV and visible, that is 200 to 800 nanometer region. Therefore, in our photochemistry we are dealing UV visible. Therefore, when you give a photon of this region, all these changes will happen there. Therefore, we want to account all these things. Therefore, it is quite complex. Electronic spectra is quite complex. You will learn more about these details, fine details of these things will be discussed in electron spectroscopy. But you remember that. And you also remember that the energy order is E translation is very much less than E rotational, less than E vibrational, less than E electronic. Okay, I will tell you delta E of translation is, delta E rotation is 1 centimeter is minus 1. Wave number, this is wave number. Okay. If you have a HC nu bar is 1 centimeter, there will be a rotational energy change. If it is a delta V vibration is equal to 1000 centimeter raised to minus 1. Okay. If it is electronic, delta electronic, there will be 10,000 to 1,100,000 centimeter. That is centimeter. The wave number of in this order, or the photon of this wave number order will be given, only there will be electronic transition or electronic change. Here our photochemistry happens. Therefore we have to take care that when we give a photochemistry, when we discuss a photochemistry, when we discuss electronic transition, it will be accompanied by rotational or vibrational vibrational transition also. I will show you a schematic representation. Suppose it is a ground state electronic level. Let me check the video. Okay, ground state electronic level. Suppose it is a first excited electronic level. You know, each electronic level there is a different vibrational level. It is a all these, when this is called a vibration V0, V1, V2. All these higher vibrational levels are within the electronic level. That is, when the molecule vibrates in this higher energy level, still its electrons are in the ground state. That's the meaning. You got the meaning? When a bond is vibrating at this higher energy level, still the electrons are in the ground level. Similarly, in the excited level also, you have a following vibrational level. Okay. Suppose a bond is vibrating at the ground level, that doesn't mean that there is no electronic excitation. There will be electronic. An electron has been excited into higher level, but in that higher level, it has a very low vibration. You got it? That is this meaning. Now, within the vibrational level, you have a different rotational level. Suppose this different rotational level also. Okay, this is possible. Fine. Therefore, this is a schematic representation. That when there is an electronic excitation, there will be some vibrational excitation also. This will be explained by Frank contact principle. I would like to discuss it in next video. Now we are going to discuss the selection rule for electronic transitions. When electron is undergo transition from one level to another, it should follow some selection rule. That is based on selection rules. Electronic transitions have been classified as allowed transition and forbidden transition. That is, transition happens, but certain transitions are allowed, certain transitions are forbidden. Generally speaking, allowed transitions, whether it is absorption or emission, it will be high intensity. Suppose there is an emission from allowed transition, the color of the emitted light will be very intense. Forbidden transition, the case of forbidden transition, it is a low intense color. It is a low intense. Forbidden transition, it will be low intense. Okay, this is our another classification, allowed and forbidden transition. Now there is always a question, which is allowed transition and which is not allowed or forbidden transition. The allowed transition has been selected by following selection rule. That is, if the transition follows certain selection rules, then we can say that those transitions are allowed. Okay, we can discuss one selection rule. The first is selection rule based on energy level selection rule. Energy level selection rule. That is delta n. That is, delta n can be plus or minus or plus or minus 2 or plus or minus 3 or plus or minus 4. That is, suppose you have an atom, it has different energy level. We have drawn it in hydrogen spectra. You know, hydrogen spectra, this is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to... You can have any transition is possible. Similarly, I write like this, not only the excitation but also de-excitation. Emission, you can have any emission. That is why you have different Balmer spectra, Lehman, P found. You got it because you have the transition from n is equal to 1 to 2, 1 to 3, even to infinity. Okay, that is Lehman, Balmer, Paschen, bracket, prefound, and different spectra are possible because this is possible. Any level, electronic level transitions are possible. That is allowed. Okay. Now, second is orbital level selection rule. Orbital selection rule. Second is orbital selection rule. Orbital selection rule, that is called the Laporte selection rule. Very important. During an electronic transition, during an electronic transition, the orbital change must be plus or minus 1. That is delta L must be plus or minus 1. Substitution change should be plus or minus 1. Okay. Okay, we can discuss that. We have a L is equal to 0, 1, 2, 3. These are the following orbitals or subshells. That is S, P, D, F. That is, it should be plus or. You can have a transition like that. You can have a transition from S to P, or P to D, or D to F. All are allowed. But this transition, not allowed. Similarly, this transition not allowed because it is delta L is equal to plus 2. This is also delta L is equal to plus. Similarly, S to F is not allowed because delta L is equal to plus 3. P to F not allowed. These are the allowed transition. You can have a transition from S to P or P to D or D to F. Okay, this is called the Laporte selection rule. Therefore, when there is a question of selection rule of orbitals, remember there is a transition from there. Therefore, when I will discuss coordination component in 6th semester, there will be DD transition and FF transition. DD transition and FF transitions are there. DD transition. You learn that the DD transition and FF transition because coordination compounds shows the color because of DD transition and FF transition. That is from T to G orbital to EG orbital. All are D orbitals. Okay. This transition is forbidden. No doubt, this is forbidden. That is why the transition metal complexes are weak colored. Their color intensity is very low because they are weak transition or forbidden transition. Okay, transitions are possible whether it is allowed or forbidden, but DD and FF transitions are called we will call forbidden transition. Then parity, third is parity selection rule. This is something new. Parity selection rule. Maybe new. Parity selection rule. Parity selection rule. Now orbitals are divided into gerade end, G and U. What is G? G is called gerade or symmetrical or ungerade. This G and details of G and U will be discussed in post-graduation level. Okay, fine details will be discussed in post-graduation level. You just remember the word G and U. That is EG. I tell you, just EG. P2G. This G come from here. Okay, gerade. Yes, therefore, I just tell you S, P, D, F. S is gerade, this is ungerade, gerade, ungerade. Therefore, this I said it, this is possible. Therefore, gerade to ungerade or ungerade to gerade is allowed. But S to G or P to U are not forbidden. That is gerade to gerade or ungerade to ungerade is forbidden. Students, remember this. Okay, S to P possible, P to D possible, D to F possible. That is gerade to gerade, ungerade to gerade or gerade to ungerade. That is possible, but gerade to gerade or ungerade to ungerade is forbidden. That is called the parity selection rule. Okay, yes. Okay. Now let me check the videos because many times I have an experience. Videos is out of focus, therefore I want to recapture, reshoot it. That's why I'm checking. Now for this spin selection rule. Next is spin selection rule. This is very important. That is, during the electronic transition, spin of electrons must be preserved. Only such transitions are allowed. Only such transitions are allowed. Based on spin of the electron, we have following condition, that is singlet state and triplet state. One more is there, doublet state. That I am not going to discuss now. We will discuss only singlet and triplet now. Okay. Therefore, singlet to singlet allowed, triplet to triplet allowed, doublet to doublet allowed, singlet to triplet not allowed. We will discuss what is singlet and triplet state in detail. Remember, that is, we can say that this is thought delta S is equal to 0. Singlet to singlet, that is delta is 0. Doublet to delta is 0. Triplet to triplet, that is spin is not changed. Triplet to triplet is 0. A triplet to triplet transition where delta is 0. Doublet to doublet where delta is 0. Singlet to singlet where also delta is 0. Such transitions are allowed. But in the orbital case, orbital should be changed, but spin should not be changed. Okay? Remember that. Orbital should be changed. Delta L plus or minus 1. But spin should not be changed. Okay? Now what is a singlet state? Singlet state means two electrons have parallel spin. Two electrons have opposite spin state. Two electrons are in opposite spin state. Two electrons are in opposite spin. Triplet state is two electrons are in same spin state. Normally, this is a normal case. That is a normal case. Suppose your electron in an orbital is this. That is called a singlet state. State. Okay. Where S is equal to 0. What is S? S is equal to total spin. That is S is equal to S1 spin of this plus S2 spin of this. That is S is equal to plus 1 minus 1. That is 0. That is 0. Singlet state. S is equal to 0. Now you have two options. This is a ground state. Suppose this is a ground state. Now one electron is absorbing here. Suppose NH, you give an HNU. You give HNU. This is your ground level. One electron excited. Suppose this electron excited like this. This electron excited, spin is preserved. This is suppose minus half, same minus half state here. Here the excited state also in singlet state. Excited state also in singlet state because spin of the electrons are in opposite direction, opposite spin. Spin of the electron are in opposite state. Therefore, excited state also singlet state. Therefore, this transition is allowed. But you imagine you have another transition where your electron is this electron here. This is higher energy level. The higher energy level, your minus, this is plus is here, minus is excited, minus spin electron is excited. But in the excited state, somehow it is like this. Imagine that is possible. Somehow the spin turn around. Somehow it is like this. Okay, here S is not equal to 1, not is equal to, total spin is not is equal to 0 but 1, because this is also plus 1, this is also. Therefore, when you apply, this is called a triplet state. Why you not triplet state? Triplet state means spin state is equal to spin state calculated by the equation spin state is 2s plus 1. What is s? Total spin. In singlet state, 2 into, what is s? What is here s? Where total spin is equal to 0 because plus and minus plus 1. Therefore, this is called a singlet state. Spin state is singlet because 2s plus 1 value is 1. Okay. Spin state will be triplet. Spin state will be triplet when 2 into, what is the total spin here? 1, because this is also plus, this is also plus. Therefore 1. Suppose it is minus sign. Suppose it is like this. This is also 1 because we are taking only the magnitude. Student, okay, we will take the only magnitude in this calculation. In this calculation, we take only magnitude. If you have a minus sign, no problem because we take only magnitude. If plus 1, that is 3. That is called a triplet state. Therefore, the electron, in this case, triplet state. Therefore, in this transition is from singlet state to triplet state. But here the transition is from singlet state to singlet state. Therefore, it is allowed, this is forbidden. How do you calculate the singlet state? Singlet state will be determined by this equation or simply by looking. Electrons are in opposite spin. Electrons are in opposite spin. Here electrons are in parallel spin, then it will be triplet state. Therefore, if electrons before the excitation in opposite spin, then after the excitation there should be in the opposite state then only that is the allowed transition. If it is in parallel spin or same spin, then it will be the forbidden transition. Okay, dear students, therefore the delta S should be 0. Delta S should be 0. Now another one, fifth one is very careful. J value must be 0 or plus or 1. J is called the total angular momentum. Total angular momentum. This will be discussed in post-graduation, and I have a plan of sharing a video of turn symbol. That is not our syllabus, but there are questions from JAM syllabus. JAM syllabus contain turn symbol. Therefore, in future I will plan that topics and I will share you. Therefore, it will be more clear. Anyway, J value must be, delta J value must be 0 or plus or 1. How do you get the J value? J value is obtained from turn symbol. Turn symbol is a method of representing the state of an atom or molecule in a given electronic level. Okay, we will discuss it in future. But a turn symbol like this, L 2s plus 1j. I will tell you one example is D3 5 by 2. This is a turn symbol. Therefore, this is called the spin state. Spin state. During an electronic transition, spin state should be same. That is, this value should be same. This is called orbital state. Orbital state. That is here D. Okay, D orbit. This is the J value state. J value state. Angular momentum state or J value. Okay. Therefore, this, when you know a turn symbol, you can simply calculate which transition is forbidden, which transition is allowed. Now, I give you two questions from the previous JAM examinations. Okay. Question is, which of the following are allowed and forbidden transition? Which of the following are allowed or forbidden transition? Which of the following are allowed or forbidden? For example, one question, P 2 1 by 2 gives P 2 1 by 2. Is this transition is allowed? Remember, this is a turn symbol. It represents an electronic state of an atom or molecule. From this electronic state, the molecule absorbed a photon and changed it into another electronic state represented like this. Represented like this. Is this transition, electronic transition, is forbidden or allowed? That's the question. Don't confuse what is this. I tell you, this is a symbol, simply speaking, a symbol called a turn symbol. I will do a separate video, not for in this classroom, but for our JAM classroom. Okay. Anyway, for any student, for their simple understanding, I tell you, it is a symbol called a turn symbol representing an electronic state. From this electronic state, the molecule absorbed a photon and go into this electronic state. Whether it is allowed or forbidden, that's all. Okay, for allowed or forbidden, this turn symbol should be understood that this head, this upper part represents spin state. This lower part, this hanging part represents J state. This is the orbital state. This state, that is delta S, should be 0. Delta L, middle state, should be plus or minus 1. Delta J should be 0 or plus or minus 1. Look at here. 2, 2, 0. Therefore, this is 0. Allowed. PS, that is PS or SP, then plus 1. Allowed. This is 0. Therefore, this transition is allowed. Allowed transition. Very simple. You are getting one simple one 4 mark for your competitive examination if you remember all these tricks, all these concepts. Another one I will tell you, another question, if this will finish. 2, 1 by 2, D, 5 by 2, 2. Another transition. Okay, S is equal to, delta S is equal to 0. Okay, satisfied. PD, S, P, D, F. PD transition allowed. Delta L plus or minus 1 allowed. But here, this is 0.5, this is 2.5. What is the difference? Difference is delta J is equal to 2, not allowed. Delta J failed, not allowed. Therefore, this is a forbidden transition. Forbidden transition. Okay, students, very simple. Very simple. Therefore, what is your topics? Your topics only spin state. Our university syllabus topic only spin state. Spin state 2 types, singlet and triplet. I will tell you some more details of the spin state. Okay, some more details. Please remember. I just give you some more details of the spin state. You have 2 types of spin state. Spin state, that is triplet state and singlet state. Singlet is this, triplet is this or this. Both electrons have same spin. Here both electrons have, this is singlet, opposite spin. And this is more energy state or less stable state. This is less energy state, more stable state. It is forbidden. That is the wonder of our chemistry. This is, in terms of chemical terms, this is forbidden, but it is less energy, more stable. The lifetime is here. If an electron reaches this state, the lifetime is 10 raised to minus 5 to 10 raised to minus 3 seconds. An electron can remain in this state, in this time, even 1 second possible. There are some situations 1 second are possible. Okay, but here it is 10 raised to minus 9 to 10 raised to minus 7 seconds. Nanoseconds. Only nanoseconds electrons are possible. Suppose this is your ground state. This is your ground state. This is a singlet state. And here is a triplet state. Here is a triplet state. But only this transition is allowed. Therefore, this is the route. First it goes to here, then come to here, then return. Good, you got it? There will be no this type of a route. This is not possible. Remember, my students, this is our syllabus. Okay, if from the ground state, molecule absorbs the photon and goes to a singlet state. From the singlet state, it can go to the triplet state. Okay, from the triplet state, it will. There is no direct passage from ground state to the triplet state. Why? Because triplet state, even it is less energy and more stable, but it is not allowed. Not allowed. This is allowed. Allowed. This is the wonder of our chemistry. We have to understand this chemistry and we have to enjoy this. Okay? Have a nice day. Thank you.